Hi class, Professor Anderson here. We're talking about physics again. Here we are again, talking about more physics. You guys getting bored with the physics? I hope not. Hopefully it's getting more exciting. I mean, if it's not getting more exciting, let me know and I'll start improving the situation here. Okay? I don't know what I'm going to do, but I'll figure something out. So let's take a look at one of your homework problems specifically. This usually wakes people up. And this is a problem that we looked at last time. We had one of the students demonstrate how to do this problem. And I just wanted to do it again to show you how I would approach the problem. And remember those 6 steps or 5 steps that we have for dealing with force law problems. Okay, this is the approach that we're going to take. And this is the hanging beam problem. And the idea is we have a big heavy beam that's hanging from 2 cables, and we need to figure out what the tension is in those 2 cables. So here's our beam M. We have 1 cable going up like that. We have 1 cable going up like that. And we're going to tell you what the angle is for those 2 cables. That's theta 1. This is theta 2. Okay, and you would be given some numbers for both the mass and theta 1 and theta 2. So, let's see. We're wanting to figure out T1 and T2 in this system. I've got my picture. What's the next thing that I should do? Let's go with Chris. Chris, what do you think the next thing I should do is?
Draw a free body diagram.
Draw a free body diagram. Excellent. So, Chris said, let's draw the free body diagram. Free body diagram is just this. Mass M becomes a dot. That beam becomes a dot. It's all concentrated at one point. Chris, what are the forces that are acting on our beam now?
You have the tension
Okay.
in one cable and the tension in the other, supporting it.
All right.
And then you have the gravity, the mass times gravity.
Good. Good. I totally agree so far. Everything looks fine. But what we want to do next is let's break up that free body diagram into components. We know that mg is straight down, no problem. But T1 is up at an angle, and so there's some component of T1 going up, and there's some component of T1 going to the left. T2 is up to the right, so there's some component up and some component to the right. So I'm going to need 2 more forces going up. 1 due to T1 vertical, 1 due to T2 vertical, and I'm going to need 2 more forces, 1 to the left, 1 to the right, for the horizontal components. T1 is on the hypotenuse. Theta 1 is right there. What is this side of the triangle? Lauren? Lauren? What do you think? What's this side of the triangle?
It'd be cosine.
Okay, T1 cosine theta 1, and then obviously that has to be T1 sine theta 1. Perfect, right? Our angle's there, the right angle is there, so that's what it looks like. We can do the same thing for the other triangle for T2. T2 is going to look like that. And if this is theta 2, and that's our right angle, then the top is T2 sine theta 2, and the left side is T2 cosine theta 2. All right, so now we've identified all those forces, and now we can put them on our free body diagram. The one to the left is T1 sine theta 1. The one to the right is T2 sine theta 2. The one going up is T1 cosine theta 1, and the other one going up is right here, T2 cosine theta 2. And so now this is a very nice looking free body diagram because it's in components. We have broken it up into X and Y components.